Hello, my name is Sean, and welcome to our first episode of Surviving Networking and IT. And this episode comes from an event that a fellow Discord member was having, where he needed to have two internet circuits, and one internet circuit was typically dedicated for some of his devices, and then the other circuit was for everybody else. But there was some caveats with that, and I'll bring it on screen to show us what we're working with. So this is the diagram that he came up with, and this WAP LTE is a Mikrotik LTE router, and this goes out, of course, to the internet through LTE. And we have 1, 2, 3, 4 devices that need to go out to that by default. And one of the devices are connected through a switch right here. And feeding through the switch will go out through this LTE router. However, there are other devices in the family that need to go out this ADSL circuit. Also noted that this DSL router combo is not manageable, so nothing you can do in there to kind of finagle routing or anything of the like. It's very bare bones, basic, and provided by the ISP, and nearly impossible to swap out from what the person was telling me about. So I went ahead and converted this diagram to something a little more understandable by me. So I went to diagram.net and converted it over to this. And in here, I've labeled it over here, the ADSL modem router. It goes out through its WAN port to the internet, and its LAN ports are connected for these family devices of so. On the other side, we have this Mikrotik LTE router. Through its WAN connection, which is the LTE interface, hits out to the internet. And through its wireless connection, it connects to PC1, PC2, and one of the Raspberry Pis. And in the middle is the switch, which connects another Pi. And this needs to connect into this LTE router by default. Now, the way I solve this, and it seemed to work out for the fellow member, is with VLANs. Essentially, we have two separate networks that don't need to talk to each other on a daily basis. And in reality, it's going to be 3 networks, because the way Mikrotik does VLANs can be a little goofy sometimes. So I went ahead and separated the network out just to make it a little bit easier. So one network right here is this wireless network right here. Another network is just this Pi. And the third network right here is these family devices. Now, because the person wanted to have these devices fail over to go through this ADSL modem router if this ran out of data, because it's common with LTE circuits that you run out of data, wanted to fail through this, send the traffic over here, and then out to the internet. The vice versa wasn't discussed, so these devices do not need to go out through the LTE router at all. And I don't think with this setup you'd be able to do so without a lot of finagling. So let's go ahead and talk about this a little more in detail. Let's see if I can zoom in. So between this LTE router and the switch on Ether 1, which in reality is going to be Ether 2, at least in our example, and it's going to connect to port 2 in the switch. Now this is going to have 2 VLANs on it. VLAN 50 is going to be used for this device down here, this Raspberry Pi. And VLAN 100 is going to be used for the through VLAN, which goes from over here, through the switch, out over here untagged, hits this ADSL modem, and then that way you can head out to the internet as so. Why? The reason we had to go about it this way is the ADSL modem over here had no ability to add any additional networks and could not make any changes whatsoever. So anything you plugged into this ADSL modem got an IP from this DHCP service on this modem, and essentially this port over here need to get onto that network. And I'll show you how we're going to do that. We're going to skip the DHCP on that and just do a static IP for this. So I'll bring up GNS3, and I have the basic layout already set up. So right now we have these PCs and Pi connected to the LTE router. We have this extra Raspberry Pi right here, which we can connect to the switch. And we have this ADSL router connected to the family PCs. And if I go to the family PCs, I'm going to see if I can ping out to the internet. Ping google.com. And looks like it can ping out to the internet just fine. Let's do the same thing for these PCs over here. And these computers can go to the internet through their own router, through their own internet connection. So now let's go ahead and get this switch in play. So we're going to go ahead and connect. Well, let's find out what the ports are set up for on this. So we go to configure. So right now I have port 2 set up as a access VLAN, which means it's an untagged port for VLAN 100. We have an untagged port for VLAN 50, that's on port 3. And we have a trunk port, which is tagged, and that's going to allow all tagged packets across in this simulation right here. So we're going to go ahead and connect ETH1 to Ether2 right here. We're going to connect Ether2 on the switch to Ether2 right here. And we're going to connect Ether3 to this Pi. Now, let's go ahead and bring out let's go ahead and notate this a little bit to make this a little bit easier for us. Add note. 100 tagged. And actually, we'll drag this down to describe this down here. VLAN 50 untagged. So that's what we have currently set up. We do need to set up this trunk port right here. We have it physically connected. We're going to go ahead and console in. And okay. So let's, for Mikrotik, let's go ahead and see how many IP addresses are on this device currently. So IP addresses, parent. And as we see right here, we have two networks already connected. Ether1 is the WAN connection in my instance right here. This LAN bridge is for these PCs down here. But we need a third network setup. Actually, in reality, we need two more networks set up. One for this VLAN 50 and another one for over here. We need a point-to-point network for this ADSL router. Now, we could just turn up DHCP client on this on Ether2. However, in case they want to do something manual down the road, I'm not a very big fan of that. So we're going to go and do a static IP for that. So IP address, I'm going to add And I believe this one I've set up for 192.168.0.1. Let's see how that network is set up. IP address, print. Okay, so its LAN bridge is set up for 0.1. And I believe the DHCP is above 10, so I want to use .2 for this other side. So add address 192.168.0.2/24. And we're going to use interface. Now, do we have any VLAN interfaces set up? Looks like we do not. So that's what we're going to do. We're going to set up the interfaces first. So we're going to go to interface, VLAN, add, name, and then we're just going to call it VLAN 50 with a vid of 50. And the VLANs have to live on some physical interface or some other logical interface. Because in this instance, it's going to live on Ether 2. We're going to just type in Ether 2. And we're going to rinse and repeat for VLAN 100. Ether 2. And now if we do a print, we have VLAN 50 and VLAN 100 living on Ether 2. Now we can set up an IP address on VLAN 50 and VLAN 100. We'll do VLAN 100 first, so that's what we was doing before. Add address address 0.2/24 interface VLAN 100, and that should be it. And if we do a print, we now have 3 networks on this router. Now we need to add a 5th one. I like to keep things memorable if I can help it. So we're going to go ahead and do add address 10.0.50.1/24. Interface VLAN 50. We do a print. Now we have our 4th network that we needed for this. Now, technically, you don't need a VLAN 50. You could just leave it untagged and just straight on the interface itself. But I think it's a good habit of getting used to using VLANs so you understand where the traffic is coming and going on your different devices. So let's go ahead and try to see if we can ping across to the other side of the VLAN 100. So 10.192.168.0.1. And I can ping across just fine. So now that we verify that I can ping, we have this device right here. And we're going to console into it. Now, right now, I can't find a DHCP server because we haven't set one up yet. So, we're going to go back to this router and add a DHCP server to this. So, IP DHCP server. And we're going to do add. So, what we can do, I believe, is do the setup wizard. Setup wizard for Mikrotik for DHCP makes things a lot faster because it makes some assumptions about what you want to do, and then you can fill in the gaps without having to manually try to remember everything. So we're going to do setup. Now, in Mikrotik's world, an interface is an interface and is an interface. Now, let it be for logical or physical. So a VLAN interface is a logical interface. So we're setting up the DHCP server for VLAN 50. It shows the address space, which is correct. The gateway, which is going to be this router, 50.1. The addresses to give out, I'm going to start at 51 go to 200. And DNS servers. I'm going to set it to the internet, so quad 8. Lease time 10 minutes. That's fine. And now the DHCP server set up. Let's go ahead and now run DHCP. And my Outlook calendar is blowing up as usual. So let's go ahead and ping out to the internet. So let's go ahead and ping Google. And we can ping Google just fine. That is wonderful. So now, essentially, the traffic is going from this Pi 1 through the switch to this WAP LTE router out to the internet. So let's go ahead and update this, and let's duplicate this a little bit. Oh, come on. And it's going to be tagged. And VLAN 100 tagged. Now, is there anything that we're missing from right here? Essentially, we have our two networks set up and we can connect through, but we want to see if we can fail over this WAP LTE to over here to this DSL router. Now, the one thing we have to be mindful of about all of this is that we have a couple different networks here that live on this router right here, compared over here. And because this DSL device doesn't even know this is a router over here, we're going to have to add an additional NAT to the scenario. And while double NAT and triple NAT is not recommended, some instances like this, you have no choice. So let's go ahead and look at the routing table first. Let's clear this. IP route. We're going to print. So we have the first default route, first and only right now, pointing out the gateway, which is connected to my internal internet. And then we see all the connected routes that the router has a leg on. So essentially, we want to have this router to be able to go out the other internet if we can help it. So we have to add, and I believe it's destination address. Yep, 000/0. That's for all addresses not specified. And then we're going to go through adding the gateway. Now, the gateway that we know about is 192.168.0.1. And I think that's all we need. We're going to set this distance to 20. Print. The additional static default route will show up and has a different distance. Now, let's go ahead and do a tools trace route. And tools trace route, and we'll do out to, Google. Okay, so now we see these number of hops it takes to go out to the internet from this router. And it immediately goes through the first internal internet option and down out to the rest of the internet in the world. However, let's go ahead and change the route to go out through the other DSL and see what happens. IP route set. And this is going to be rule number 1 actually. Set 1, distance, and actually it's going to be set 0 because we want to change the first rule. So set 0, distance to 30. We cannot change the static route. Now, there are ways of getting around this, but let's go ahead and what's the best way of going about this? Yeah, we'll go through. We'll do it through the proper way of the DHCP client. IP DHCP client. Print. We'll set 0. Default route distance, and we'll set that to 30. IP route print. And now the original default route has been put second in line compared to the original static route we put out there. Let's see if we can ping out to the internet. Hey, we can ping out through the internet through the other pipe. Let's go ahead and prove that with a trace route. So, pool trace route, and we'll ping out the Google. And now we see an additional hop. So we're hopping over from here to here first, then out through the internet, and then on the routes out through the ISP networks. But what about the downstream devices? Can those now get out through the internet? Well, let's go ahead and try PC, this Pi 1 first. Let's go to console, and we'll go to this other PC as well. Let's ping Google. Ping Google again. And we're getting a request timed out, request timed out. The reason why this is timing out is because these devices are on different networks compared to this device on this leg right here. And when you do that and the other device doesn't know about these networks, you have to use NAT. So to solve this, we're going to go over here. So we're in our LT router. We're going to go slash IP firewall, NAT, and we'll see what we have for NAT so far. So right now we have nothing that's out of the default. Now this is by default. Mikrotik uses ETH1 as a default route. I'm sorry, default NAT. So we export, we'll see the mask grid right here. The NAT for ETH1. So we actually need to have another additional NAT for ETH2. And actually it's not going to go out ETH2. It's going to go out VLAN 100. So let's go to add, action, mask grade's fine for now. Chain, source NAT, out interface. And we're going to go out VLAN 100. And now we have that additional NAT put in place. We can do a print. It shows both of them now. And we'll go back to this Pi, which was behind the switch. We're going to ping. And now it can get out to the internet. And this device can also get out to the internet. Now, if we do a trace route, we can actually see the hops it takes to get to the different places. Let's see if this has trace route. I hope it does. No, it does not. Oh well. But the whole point is that this device is literally taking the traveling going through VLAN 50, through the switch, going into this router, then doing a U-turn via NAT, going out VLAN 100, through the switch, back over through the switch, out through this DSL modem, out into the world. And then the same thing with these PCs. These PCs come in through their standard connection, and then they're going out VLAN 100 to this switch over here and out to the internet. Now, the person want to be able to fail back and forth. There's two ways of going about this. Essentially, you need to change the route distance that allows you to prefer which route you want to have. So let's go to IP route first. print. So the smaller the number for the distance is the more preferred route. And if you have a more preferred route, it'll go up that particular interface or gateway. So it's saying, hey, for this right here, for this route right here, the preferred gateway is this. And then the system automatically finds which network this gateway is on. And if you look right down here in the routing list itself, it's on this network right here. And then this is the preferred source, and it's on VLAN 100. And then if you go for this default route, you find this gateway, and then on that, it finds it within this specified address, is using this preferred source, and that's the interface it goes out on. So essentially, the person that needed to make any changes, they could do it two ways. They can make just a static route on their DHCP for this LTE, and while that may or may not work, they can do that and it should take over. Or in reality, what the best way they need to do is go to the DHCP client and change the routing distance. So set 0, because I only had one DHCP client, default routing distance, and they can change that from 0 to 30 or from 30 to 0. And every time they do that, or routing distance, sorry, 1 to 30 or 30 to 1, and that will change the preferred route. We'll do a print again. And now that gateway is preferred. And we go through here. These devices can still get out. And now everybody is happy. Let's go through tools. Trace route. And now we see that additional hop is now gone. I hope this little how-to described for this particular scenario of how to have two internet circuits and have devices trunk through a switch and how them fail over back and forth between two internet circuits is helpful. And if you have any questions, please reach out to me on the Discord. Myself and others are always available to help. And if you have any ideas for another topic you want to go over, let me know, and I'll gladly help out with that. See you later. Bye.